Hello everyone, this is Sat Sandeep from Vignans Nirula, working as assistant professor in CSE department. So today we are going to see the applications of data structures. In our previous lectures, we have seen what is a data structure and why we need data structure, and we have seen what are the hierarchy of the data structure and typically telling what are different data structures that are available. And we have seen the overview of the data structures in our previous classes. And now we are going to see the applications of data structures. Applications of the data structures includes the applications of arrays, stacks, linked lists and graphs. And here we are not going to touch all the concepts that are involved for these applications. We are going to simply see the applications that we are going to use in our day-to-day lives. It starts with how the data is generated. The data is generated from multiple sources, like sources from the digital world that are equipped with the smartphones and handheld devices, and also the data that is generated from the previously owned microprocessors that are running over the IP stacks, and also the data that is also generated from the IoT devices that are newly launched. And also in the typical use cases, when we see the near future in 2025, there are 50 billion devices that rules the planet, and which generates a lot of data, and this data has to be collected and also it has to be stored, and it has to be used by the applications. And for this we need a proper data structures. And for the data structures have a huge amount of applications that makes it possible. And today we will going to see some of the applications that are used in our day-to-day life. Let us see. The first data structure that we are going to see here is the arrays. Array is the homogeneous collection of data items. It means that all the data items which you put in the array are of the same type. For example, in this array we have all the alphabets, means the character array. This is a character array. And here the data can be accessed like this. So typically in an array, a data can be accessed by knowing its index. It means like you are going to access it directly. Suppose at data item at index 4, so you are going to simply get array at index 4. 4 is equals to the data item, which is A. So in this way, at any part of data, if you know the index, you can access the data directly. This gives the immense strength towards for the arrays for accessing the data. And when it comes to the multi-dimensional arrays, so there are more than one dimension here, so that's why we have more than one index here. So here the rows are identified by row index and columns are identified by column index. So here when we want suppose item at second row and fourth column, so it is done by A of 2, 4. So now let us understand the typical applications of these arrays. The first application is movie ticket booking. So we all love movies. So when it comes to booking the ticket online, so nowadays we have so many platforms that enables us booking the tickets online, like Book My Show, Paytm and all these applications. And here when it comes, it gives a typical layout like this, and the user can select the seat and he can book the ticket. So here if a user select a seat like, it translates towards a two-dimensional array here. So it contains a row, particular row and particular column. For example, here the seat which I have booked here is in row 3 and column 4. So it can be translated like this. So seat of 3, 4 is booked. Okay. So this is the way where we use the data structures. The next data structure we are going to see here is the stack. Stack is another linear data structure that is used for accessing the data in a LIFO manner. LIFO is nothing but last in first out manner. So here if you see the stack here, so it contains two operations, that is push. Push basically push the data into the stack, and pop is the operation that takes the data from the stack. So let us see what are the typical applications of the stack. So the first application here is the web browser. So when we all surf the web, and here when it comes to the web browser, it will be associated with a built-in stack. So here why we use this stack is, here we will see. When we try to visit a website, so suppose a Nirula page, so it will be automatically added to the stack like this. It will be pushed onto the stack. Next, when we want to visit another web page, suppose say google.com, so it will be automatically again pushed onto the stack. The link is pushed onto the stack. So this way how many pages you have visited, all the pages links are pushed onto the stack. So whenever you want to go back to the previous page, you simply hit back, right? So when simply hit back, what happens here is the one which is in the top of the stack will be popped out, and the one which is previously, that is the Nirula page, will be displayed back. So this is how your stack actually works. So next comes the linked list. So linked list are the linear data structures that have the nodes and as well as the links that connects these nodes. So here basically the nodes actually stores the data. It is like a simple train kind of thing. So which have starting as a head node and towards the tail, all the way to the tail. So basically when you are going to search for a node, you have to start from the node and you have to visit each and every node until you find the particular node. So this is called as a linear search. So here let us see what are the application of this. So when we all love music. So when it comes to the music, here the music we will maintain a playlist. So here the playlist contains, suppose we have 3 songs in our playlist. So the first song, when you start listening and then we go to the next song, so there will be a link associated from the first song to the second song. And when you start listening to the third song, there will be another link from the third song. So this creates a kind of linked list. When you see here, it creates a single linked list. And there are certain use cases where from the third song, you can go back to the first song, so in a repeated mode. So in this way, it is linked back to the first song. So this way, you are going to have a circular linked list. So next comes the graphs. Graphs are the non-linear data structures. So here the graphs are the example of the non-linear data structures. So here a graph is a combination of vertices and edges. And these vertices are nothing but the data. Vertices carries the data and edges are used for connecting these vertices. And let us see what are the applications of these graphs. So the first application here we're going to see is the navigation. So when it comes to the navigation, Google Maps plays a very important role here. So when you want to go to a particular destination, you go and hit the destination there, and it will show you the best possible route, and it also shows you what is the time taken and what is the distance, like that. So how it is able to compute this? So this is done by using the graphs again. So here all the points on the Google Maps are translated towards the vertices, and these edges are nothing but the distances from each vertices. And here, so it starts from the first vertex and it's gonna visit each and every vertex and see the distances from each and every vertex, calculates the distance between their neighbors. And likewise, they will update the distance towards the final vertex. And this way, from any node, any place to any other place, the Google can simply calculate the distance. So now let us do a quick recap of what we have learned today. We have gone through many applications on the data structures. That includes arrays, which is used for booking the tickets online. And the next data structure which we have seen is the stack, which is used for browser and by storing the previous pages. And the linked list, that is used for shuffling the songs and accessing the previous song and next songs. And next, the graph data structure, that is used for navigating through Google Maps. And by this I end up today's lecture, and in the next lecture we are going to see in detail the concepts on arrays. Thank you.